Hello, welcome to Unit 4, Lesson 1. This is Professor Blackman. In this lesson, we'll be talking about the introduction to polynomials. We'll start out by looking at vocabulary terms. Then we will take and evaluate polynomial functions. We'll combine like terms, and we will find the opposite of a polynomial by subtracting polynomials. Let's go ahead and get started. All right, so we're going to start out by looking at some terms. Monomial. A monomial is a single term. And so we're going to go ahead and look at this big term of 2x to the third plus 8x squared minus 17x minus 3. So in this box, I have it broken up so we can see, all right, what is this degree of this single monomial term? Well, that would be a 3 because its exponent is a 3. Here, this has an exponent of 2, so its degree is 2. This term, negative 17x, has a power of 1 because there's that understood 1 as an exponent, and this has a degree of 0. So when you are looking for the degree of this entire polynomial, you just find the highest number, which of course is 3. And when you look here, the leading term is 2x to the third, because that's the term that's out in front. The leading coefficient is the number that's in front of the variable. That would be the 2. And the constant term would be the number at the end, typically at the end. So we get negative 3. Now let's look at this next term as 6x squared plus 8x squared y to the third minus 17xy minus 24xy squared z to the fourth plus 2y plus 3. So this is a very long polynomial. So the degree of this polynomial is 2 because it has an exponent 2. Now this one has two exponents, a 2 and a 3. So that's 2 x's and 3 y's all being multiplied together. So that's 5 variables. So we can find that 5 by adding the 2 and 3. This is x to the power 1 and y to the power 1, so that's a 2. This is 1, 2, and 4, so that's 3 plus 4, which gives you 7. Power of 1 and 0. So the degree of this polynomial, you're looking at the biggest number, which is 7. So let's look at the leading terms. So that would be the first term. So that would be 6x squared. And the leading coefficient is the 6. And the constant term, the number at the back end, which is a 3. All right, let's go ahead and look at some more examples. All right, so in this one, we're going to be evaluating a polynomial function. So this is very similar to what we've done in the past with function notation. So you're just going to take whatever values of x you have and plug in to each x. So this is 3 times 4 squared minus 2 times 4 plus 5. So we get, when we simplify exponents first, that's 4 squared, which is 16, times 3, which is 48, minus 8 plus 5. So that's 40 plus 5, 45. All right, let's plug in the negative 2. Put the negative 2 in for each value of x. And then simplify. Negative 2 squared is 4, times 3 is 12. Negative 2 and negative 2 give you plus 4 and plus 5. 12 and 4 is 16, plus 5 gives you 21. And now we plug in 0, so that's 0 minus 0 plus 5, giving us 5. All right, let's look at our next example. All right, so we're going to evaluate this polynomial here. Plug in there, plug in there, and plug in there. So that's 9 times negative 1 cubed plus 8 times negative 1 squared minus 4 times negative 1 minus 9. So when plugging in a negative 1, all you're really doing is paying attention to the signs. Negative, negative, negative makes negative times 9, so that's a negative 9. Negative and negative makes positive times 8. You have plus 8. Negative 4 and negative 1 gives you plus 4. And then minus 9. All right. So we get negative 9 plus 8 gives us negative 1. Negative 1 and 4 give us 3. 3 minus 9 give us negative 6. All right, let's plug in the 0, and we get 0 plus 0 minus 0 minus 9. So that's a negative 9. So let's go ahead and plug in a 1. So plugging in a 1 pretty much means that we're just going to add the coefficients, because everything's going to stay the power, unlike what we did originally where we had to pay attention to signs, because this is going to keep everything the same sign. So we get 9 plus 8 minus 4 minus 9. Those 9s cancel, and we get 8 minus 4, which is 4. All right, let's plug in a half. So half raised to the power of 3 plus 8 times 1/2 squared minus 4 times 1/2 minus 9. So that gives us 9 over 8 plus 8 over 4 minus 4 over 2 minus, and I'm just going to put this 9 over a 1. And then since we have an 8 and all these go into 8, we will put them all in terms of 8. Double that one, top and bottom, we get 16 over 8. Multiply this one by 4, we get 16 over 8. Multiply this by 8, and we get 72 over 8. And that will simplify. So this and this will cancel, because 16 minus 16 gives you 0. And then we have 9 minus 72, which will give us a negative 63 over our denominator of 8. All right, let's look at some more examples. All right, so here we need to collect like terms. So when or combine like terms, depending on what your textbook wants to call it. So what we're going to do is look for like terms. And so with like terms, they need to have these same variable parts. And by variable parts, I mean the same variables, and those variables need to have these same exponents. So what we're going to do is look here and look at our x's. So we have x's and we have y's. I like to underline them so I can tell them apart. So I have 7x minus 4x, which gives you 3x. A negative 2y and a 6y, or 6y minus 2, gives you a positive 4y. Now we cannot combine x and y's because those are different variables. All right, let's look at our next one. We have a, and a. So those are our 3 like variables. So 3a plus 8a minus 4a. So 3 and 8 give you 11. Take away 4, you're at 7a. And then we have 9, a 2, and a 7. So 9 minus 2 gives me 7. 7 and 7 give me 14. So that is what that one looks like simplified. Let's look at some more examples. All right, so I'm going to look, and I'm going to start alphabetically. So I'm going to look at my x's first. And so in this one, I have x squared and x squared. So 8 and 1 give me 9x squared. Then I'm going to look at my xy terms. Okay, so I got negative 3 plus 5, or 5 minus 3, which would be 2xy. And then I'm going to look at my y squared values. So I have 12y squared minus y squared and 4y squared. So 12 minus 1 gives me 11. 11 and 4 give me 15. 15y squared. And so now we have x squared and y squared and the xy in the middle. Right? And those cannot be combined anymore because those are different variable parts. Okay, so we're going to start here with the x squared y, and that's the two terms we have. 4 minus 5 is a negative 1, or negative x squared y. And then I'm going to look at an xy squared, and we have xy squared and 7xy squared. Add those together, and you get 8xy squared. And then I'm going to look for my y's. So right here, I have negative 3 and plus 7, or 7 minus 3. So that gives me 4y. And that is how we add those together. All right, let's look at some more examples. So here we're going to add two polynomials. But with addition in front of a parenthesis, all we're pretty much is doing is dropping the parentheses. So just take it out of the parentheses, plus or minus, be minus. Pull everything out of the parentheses. And then do what we just did in our previous examples, looking for our like terms. So I have x squared here and negative x squared. So it'll be negative 3x squared. And then I'm going to look for my xy. So I have xy, xy, negative 2 and positive 3. Give me plus xy. And then I have 3x here and a negative x here. 3 minus 1 gives me 2x. And then I have a 3 here and a 2 here. That's a minus 3 plus 2. So it'd be a negative 1. And that is how we simplify it with adding polynomials. Let's do it again. In this example, we're going to take them out of the parentheses. We get 7x squared y minus 3xy squared plus 4xy. Pull this one out of the parentheses. We get negative 2x squared y minus xy squared plus xy. And then I'm going to look at my like terms. X squared y. 7 minus 2 gives me 5x squared y. And then we have a xy squared there and an xy squared there. So negative 3 and negative 1 give me negative 4xy squared. And then I have xy. And so with the xy, I have 4 plus 1, which would be 5xy. And that is how we're going to add those polynomials. All right, let's look at some examples with subtraction. So with subtraction, we look at what's going on in front. So in front of the first one, there's nothing. So we're just going to pull that out of the parenthesis like that. But with the second one, that minus needs to be applied to every term that's here. So the opposite of 3a is negative 3a. The opposite of 2b is negative 2b. And the opposite of negative 2c would be plus 2c. Because we are applying that definition of subtraction, which makes everything that follows it the opposite of. And then once we do that, it's just like when we need to combine or collect like terms before. So we have 5a and negative 3a, which gives us 2a. Go alphabetical. We have negative 2b and negative 2b, which is negative 4b. And then we have a c here and a 2c here, which gives us plus 3c. All right, same thing we're going to do in this next example. There's nothing in front of this, so it doesn't change the first parenthesis. We're going to bring that down. And then with the second one, we are going to apply the subtraction, so we're going to make everything inside that follows the opposite. Negative 9a squared y plus 4ab minus 2b squared. And then we're going to collect our like terms. All right, so we have a squared and a squared y. So those are not like terms, but we're going to take this a squared y, put it out in front. And then we're going to look at this a that doesn't have any, a squared have any matching, so plus 5a squared. And then we have right here AB and right here AB. 4 and 4 give me 8AB. And then we have a b squared there and a b squared there. Negative 3 and negative 2 give you negative 5b squared. And that's all I have for you today. Happy studying.